Hi everyone. This is the start of a series of videos describing how you can implement a fly-in menu in an Android application. Cyril Moitier on his blog described how he implemented a menu like this in an application he worked on called Prixing. And there are a few other applications off the top of my head. I think Facebook either does or used to have a menu like this in their application. I believe the Steam app on Android also has a menu like this, and the NHL app on both Android and iOS implements a menu similar to this. So he describes in his blog conceptually how he implemented this menu in Prixing, but doesn't provide any source code examples of how this is done. So I've gone through and I'm going to show how you can implement most of what he's described in these series of blog posts in your very own Android application. And I will link his blog posts on this in the description of this video. If you're an Android developer, I highly suggest that you take a read over those posts. They're full of a lot of information that's very good. So I have the Prixing app running in an emulator here, just to demonstrate how his implementation of this menu works. If you click on this button in the top left-hand corner of the app, you can see that the content slides out of the way and reveals a menu underneath. Click the icon again, or actually anywhere on the content that's still visible, the content slides back over and hides the menu. He refers to this as a fly-in app menu. I'm a little bit on the fence about exactly what to refer to it as, because really the menu is not flying in so much as the content is flying out, revealing the menu beneath. You can see that the menu does slide a little bit as it's opening and closing, but what's really happening is there's a content view sitting over top of a menu view, and the content view is slid out of the way to reveal the menu view underneath. So in this first video, I'm going to show an implementation. It's a very, very bare bones implementation of a menu like this. It doesn't contain any of the animation or any of the other features that he has implemented in his version, and his version is quite good. I hope to cover most of what he's done, but it shows a lot of the foundations that are going to be used to implement the other pieces in terms of transitioning the content and the menu as it is opening and closing. I have my basic implementation of the flyout menu running here in an emulator. You can see initially this is my content consisting of some text and a button which toggles the menu. If I click this toggle menu button, the content is shifted over to the right, revealing this menu with some buttons underneath it. If I click any of these buttons in the menu, the content shifts back over to the left, closing the menu. There's no animation or any other special features in this example. All that's happening is I'm transitioning or shifting the content view to the right to expose the menu underneath. And this is good at showing the fundamentals that are required for translating the position of these views to implement some of the fancier features later. So let's take a look at the implementation. There are three main files involved in this project. The primary one is flyout container, which is a customized view group that contains our menu and our content views and positions them on the screen in the proper way. The second is a basic activity, sample activity, which houses this example. And the third is the layout that's used in this example. You can see here that the root view is my implementation flyout container, and it has two child views. The first represents the menu containing the three buttons, and the second represents the content, which is our text and our toggle menu button. So let's take a closer look at flyout container. First thing to mention is, why does flyout container extend linear layout rather than implementing view group? And the reason is, if I implement view group, I also need to implement the logic for drawing the menu and the content views on the screen. And in this particular case, I don't need to customize how the menu and the content are actually drawn. I only need to customize how they are positioned. So any of the layouts, I can use their drawing logic and just override their layout logic to achieve the effect. And there's no point in implementing some custom drawing logic for this example because it's not necessary. If we can extend linear layout directly and leverage the drawing logic that's already there, might as well do so. So the parameters in flyout container, the first two parameters are views, the views menu and content, and these represent the menu and the content of the application. So this is our content view here. This is our menu view here. I also have a constant defined, which I call menu margin. What this refers to is the amount of the content that remains visible on the screen when the menu is open. So I have it set to a constant of 150, which means that 150 pixels of the content remain visible on the screen when the menu is open. I've also defined an enum called menu state, which contains two values, closed and open. Now, you may be asking, since there's only two states that the menu can be in, why use an enum instead of just a Boolean value? The reason is because once I go ahead and implement the animation, there's a couple of additional states that the menu can be in rather than just being closed or open. So to make implementing the animation later a little bit easier, I do this as an enum now, and I'll just add the additional states to it as it becomes necessary. The final two attributes I have, the first one is an integer current content offset. What this refers to is the amount that the content has been shifted at any given time. So when the menu is closed, which is the default state for this container to be in, the current content offset is 0. It's not shifted any amount from its default position. However, when the menu is open, current content offset will be set to a certain value. In fact, that value will be equal to whatever the width of this menu is. So at any given time, the offset of the content we can get by referencing this current content offset variable. And I also have an instance of menu state, which I call menu current state, which contains the current state that the menu is in. And by default, when this container is instantiated, the menu will be closed, so I set its current state to be closed. These are the three constructors which are just extended directly from linear layout. There's nothing custom being done here. The next customization occurs when onAttached2Window is called. And in this method, we get our references to the menu and the content views. We can't do that in the constructor because when this container is constructed, there's no guarantees that our menu and our content views have been constructed yet. However, when onAttached2Window is called, we know that those views already have to exist, so this is where we can set our reference to them. So I assume that the menu is always the first child in the view, or in our layout. So it's at position 0, and our content will always be the second child, which is at position 1. And if we go back and look at our layout, we can see that's the case. Our menu layout here, containing the 3 buttons, is the first child of the flyout container, and the content containing the text and the button is the second child. And after I get the references to those objects, I set the visibility of the menu to be gone. And the reason why I do this is because on some older versions of Android, as Cyril pointed out in his blog post, even if a view is covered entirely by another opaque view, Android will still go ahead and try to draw that view on the screen. In newer versions of Android, it's smart enough to determine that if it's covered by an opaque view, don't bother drawing it. But to make sure that we're getting maximum efficiency out of the application, I set this to be gone when the menu is closed. So that way, on any version of Android, it won't attempt to draw the menu when the menu is closed. Now, on layout is where we're actually positioning the menu and the content on the screen relative to the position of our flyout container. And on layout is passed 5 parameters. The first parameter is a Boolean called changed, and changed will be true if the size of the flyout container has changed since the last time on layout was called. Otherwise, it will be false. The remaining 4 parameters are integers, left, top, right, and bottom, which represent the position of the left edge, the top edge, the right edge, and the bottom edge of the flyout container. So, if changed is true, meaning the size of the flyout container has changed, then I need to calculate the child dimensions, and that is a method that I've written down here, which sets the height and the width of content and menu. Let's go back to the app for a second. We can see here, with the menu closed, that the size of our content is equal to the size of our flyout container. There's the top edge of the flyout container there, just under the action bar. And you can see that the top edge of our content is the same, and the left edge, the right edge, and the bottom edge of the screen are the edges that represent the flyout container and the content. So we can just set the height and the width of the content to be the height and the width of the flyout container. The menu is a bit of a different story though. We can see that the menu is as tall as the flyout container is, but it's not quite as wide. In fact, its width is equal to the width of the flyout container minus the amount of the content that's still visible. And as you recall, I created a constant called menu margin, which represents the width of the content that remains visible on the screen. So I set the width of the menu to be equal to the width of the flyout container minus however large the menu margin is, and I just set the height to be the same height as the flyout container. So once our child dimensions are recalculated, if necessary, I call layout on the menu and the content to position them in the right spots on the screen. Going back to the app for a second, we can see that the left edge, the top edge, and the bottom edge of the menu are the same as the left top and bottom edges of the flyout container. So I just pass in the left top and bottom values unmodified. The right edge, however, isn't quite at the right edge of the flyout container. It's a little bit to the left. In fact, it's to the left exactly the same amount as is in menu margin. So I set the right edge of the menu to be the right edge of the flyout container minus the size of the menu margin. And the content, we can see when the menu is open, is also shifted over by a certain amount. When it's closed, it's not shifted at all. So to lay out the content, I do so as follows. The left edge of the content will be equal to the left edge of the menu container plus the value of current content offset. And as you remember, current content offset is a variable that tracks how far the content has been shifted from its natural view. So in the app here, when the menu is closed, that value will be 0. However, when the menu is open, that value will be equal to the width of this menu. And the width of this menu will be stored in current content offset when the menu is open. So the left edge and the right edge of the content are translated by whatever value is in current content offset. If the menu is closed, current content offset will be 0, so those edges will match the edges of the flyout container exactly. When the menu is open, they'll be shifted over by the necessary amount to expose the menu beneath. And again, the top and the bottom I pass in unmodified because the top edge and the bottom edge always remain the same. This view never shifts vertically, it only ever shifts horizontally. Toggle menu is the method that actually opens and closes the menu. So depending on whether the menu is currently closed or currently opened, we need to perform a slightly different set of operations. So let's start with the menu being closed. If the menu is closed and toggle menu is called, the first thing I do is I set the visibility on the menu to be visible. If you recall, when the menu is closed, the menu's visibility is set to gone, and if I didn't call set visibility again to make the menu visible, the content would shift out of the way, but there would be nothing there. The menu wouldn't actually show up. So current content offset, which if the menu is closed will be set to 0, I set it to be equal to the width of the menu. And this is just a method that I've written here, which wraps this call to get the menu's layout params to get its width. This is a bit of a verbose call, so I just wrapped it in a shorter method. So the current content offset for the content becomes equal to the width of the menu. Next thing I do is on the content view, I call a method called offset left and right. And what this does is it shifts horizontally whatever view it's called on by the value that's passed to it. So offset left and right, if it's passed a positive integer, shifts the view that many pixels to the right. If it's passed a negative integer, it shifts the view that many pixels to the left. So what I want to do is take our content and shift it the size of current content offset. So I shift it to the right by the size of the menu. And the very last thing that I do is I set the menu's current state to be open. So if we take a look at here, when I click this button, what happens is this menu gets set to visible. I set the value of current content offset to be equal to the width of this menu. I then shift the content to the right by the size of current content offset, which is the size of this menu, and I set the menu state to be open. So in the event that the menu is open and toggle menu is called, I do a very similar set of operations but in a bit of a reversed order. So the first thing I do is I shift the content view back to the left. So I know it's offset to the right by the value that's in current content offset. So to shift it back to the left, I just call offset left and right again and pass in the negative value of current content offset. I then set current content offset to 0 because now the content has been shifted back to its original position. It's not offset at all. I set current menu state to be closed instead of open, and then I call set visibility on menu again to make it disappear. I set the visibility to gone. And the very last thing I do in either circumstance is call invalidate on the flyout container. If I don't do this, the Android OS won't know to redraw flyout container. So if this method doesn't get called, all of the translations that I've done here in toggle menu will never be reflected on the screen. The values will change within the class, but the content will never shift out of the way. I need to call invalidate, which indicates that, hey, the position or the look of the flyout container has changed. It needs to be redrawn. So taking a look back at flyout menu example here, the menu is currently open. If I click on one of these buttons, first thing it does is shift the content back to the left. Sets the current content offset to be 0 as it's now back in its closed position. I set the menu state to be closed, and I set the visibility of the menu underneath to be gone so that it doesn't get drawn. The last thing we're going to take a look at is sample activity. You can see that sample activity has a reference to its root view, which is an instance of flyout container, and it also has a method called toggle menu. If we take a look at the layout, you'll see that I've set each of the buttons to have an on-click attribute of toggle menu. So when any of these buttons are clicked, it's going to call the toggle menu method in the sample activity, which in turn calls the toggle menu method on the root view flyout container, and as we saw earlier, that opens and closes the menu. So click on toggle menu, menu opens, click on any of the buttons again, menu closes. And that's all there is to it. It's a very bare bones implementation, and in the next video I will show you how you can add animation to the opening and closing of the menu. Thank you so much for watching.